Welcome. If you just joined, we will get started in about a minute. Hi, and welcome to today's educational webcast, AR Opportunities and Cyber Challenges in Transportation and Logistic Industry, brought to you by IIoT World and sponsored by Trend Micro and RunSafe Security. I'm Lucian Fogoros, and the co-founder of IIoT World, and I'm here together with Greg Orloff. Welcome, Greg, the Chief Innovation Officer, and we'll be your host today for this virtual conference. And on behalf of my team and the sponsors, thank you for joining. Our co-founder, Carolina Rudinsky, will be monitoring the online channels, so feel free to send your question here on the chat box, the Q&A, or the Twitter using the hashtag AR_ICS. So welcome, Greg.
Great. Thank you, Lucian. Just a couple words. IIoT World is a digital media publication that covers the economic and technological implications of the transformation taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the industrial IoT space. IoT World has recently ranked by K-Core Analytics as the #1 global influencer on several topics that include industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. IIoT World's mission is to help companies create a culture of innovation and connect the smarts, industrial technology, manufacturing, sensors, and CXO decision makers. Today, we have an exciting panel representing companies such as Ether, Trend Micro, and RunSafe. In this 2-hour virtual conference, we will discuss the business challenges and opportunities facing the transportation and logistics industry, and how we see this sector changing as a result of broad AR adoption. Then all our attention will be shifted to the ICS security issues. Our panelists will discuss cybersecurity risks and threats in the industrial environment. Also, they will provide insights on how to prevent rather than detect an entire class of malware attacks, and will explain what type of solutions can be used for better cybersecurity. Our first session is entitled Augmented Reality in the Transportation and Logistics Industry. In this session, Jeff Wheelwright, Director of Marketing Communications for Ether Incorporated, will outline the business challenges and opportunities facing the transportation and logistics industry. He's going to explain how an enterprise augmented reality management platform can be used to meet those business challenges by transforming the productivity, accuracy, and safety of your workforce. He's also going to discuss how we can see the transportation and logistics sector changing as a result of broad AR adoption. Jeff has been a technology journalist for more than 25 years, and he has worked for names that you would recognize, such as the Times of London, the Financial Times, Newsweek, Time Magazine, The Guardian, and trade publications such as Computer World and GeekWire. Jeff is now the Director of Marketing Communications at Mountain View, California's based Ether Incorporated. He has written 3 ebooks for Ether about the use of AR in industry, covering several different sectors. So please allow me to introduce Jeff.
Thank you very much, Greg. Yes, I'm Jeff Wheelwright. I am the Director of Marketing Communications here at Ether. And I very much welcome you to today's session. We've got a lot of interesting things to talk about, and I look forward to reviewing them with you. If we could, yeah, okay, there's the next slide. Yeah, so what I'm going to do is start off by just talking a bit about augmented reality. First of all, explaining what augmented reality is, then looking at how it's evolving to meet the needs of enterprises, and particularly industrial enterprises. Then we'll look at the major business issues facing the transportation and logistics sector. Following that, we'll look at how augmented reality specifically can help transportation and logistics companies tackle the business issues that they face. And then finally, look at some of the specific challenges in implementing AR and some strategies for how those challenges can be met. So in terms of what is augmented reality, what we typically say is that it's a set of capabilities delivered across multiple form factors, operating systems, and devices that includes the ability to show others what you're doing via live video, receive and send content from within your field of vision, and control the devices in ways that are useful to you. In the case of smart glasses, that means you can work hands-free with the control provided by touch, voice, gestures, or gaze or eye tracking. So you can see here, I've divided this up into, first of all, the three kinds of hardware that you would typically use. So that's smartphones and tablets, then smart glasses, and I'm including both the monocular and binocular devices. And then in the middle column, you'll see the typical operating systems that people are using. Many of the smart glasses in particular are Android-based. We've got ARKit and ARCore as the flavors for iOS and Android to support augmented reality. And then finally, you'll see a set of the devices over on the right-hand side. You'll see there a couple of the monocular devices, and as the name suggests, you see the display in one eye, and then an example of a binocular device where you've got a screen in front of each eye, and that there are pros and cons to each of those. So in terms of what you can actually do with this technology, here's just a sample of some of the things that you can do. So you've got on a pair of smart glasses, or you're using your smartphone or your tablet, and you can use that to call a remote expert. Now, if you're doing that with a pair of smart glasses, then you can actually do that hands-free. And you can continue working on whatever it is you're working. In the example you'll see here, somebody's working on an aircraft engine and they want some help. So they're able to call a remote expert who can walk them through a process for maintaining this particular piece of equipment. And they're able to point to things and have the remote expert see exactly what they see. The next thing is that you can bring in your supply chain as needed in a three-way troubleshooting call. So what that means is that if there are, in things like an aircraft engine, you've got a number of potential suppliers and a number of potential points of failure. So being able to bring in people from the supply chain is extremely useful. Then you can have work instructions delivered directly to your field of vision, and that's what you see here. So this is the first step in a multi-step procedure to conduct a repair or maintenance on this particular aircraft engine. The material that you have available to you to do this work can take the form of PDFs or existing digital photography or videos or audio, and all of that can be accessed via the smart glasses. Offline, you can also create, edit, and distribute the work instructions to the workforce that's wearing the smart glasses. So the work instructions, like the one you see in this slide, can be created just using a standard web browser. And finally, you could also see the performance of those work instructions. So if you have a complex series of, say, 20 work instructions, but you're noticing that the job that you would expect somebody to be able to do in, say, 3 hours is actually taking 4 or 5 hours, using work instructions delivered by smart glasses, you can say, oh, well, there's a delay here in step 8, step 16, and perhaps step 19. You can drill down and see what the challenges are, and then talk to the workforce and get an idea of where the challenges lay. Just a little bit about our company. we were founded in 2012, so we're actually one of the pioneers in the augmented reality industry. And we've been focused on enterprise augmented reality from the start. And at the beginning, there was actually very little in the way of augmented reality hardware, particularly smart glasses. So we started investing in developing hardware almost as a test harness for enterprise software. And we did that for a number of years, and then a couple of years ago focused solely on enterprise software for augmented reality. Our goal is for the software to be simple. What we've learned over time is that if it's not simple, it's not going to get used. People who are working in industrial environments, they've got jobs to do, and if the technology you provide them doesn't help them do their job and isn't simple and easy to use, they're not going to use it. The last thing I wanted to tell you about Atheer is that we recently pioneered something we call the Augmented Reality Management Platform, and I'm going to tell you about that right now. So the Augmented Reality Management Platform is based on seeing four key forces at play in the business world. First of all, there's velocity. So velocity is driven by innovation, ever faster cycles of technological adoption, and seeing innovations that once took decades to achieve are now being shortened to a few years or less. And you can see that in everything from computers to smartphones to AR itself. Those development and adoption cycles are getting faster and faster. The next force that we see at play is connectivity. So in order to meet the needs and expectations of consumers, people are increasingly expecting their devices to be connected, and the industrial world is no different. The third factor at play is complexity. So in order to thrive, enterprises have to be fast, nimble, well-informed, competitive, and optimized in everything that they design, produce, sell, deliver, and support. The complexity actually starts with the products themselves, which increasingly incorporate raw materials, components, and parts from suppliers around the world. And they're increasingly making use of software and services as a key differentiator. So they're more complex. And finally, scarcity. So while all these forces are at play on business, they have to deal with a fourth element, scarcity. So given the complexity of the products and services enterprises are building, selling, and supporting, there's a scarcity of well-trained people to support them. And even in industries that have a history of having highly skilled and experienced technical industrial workers, many of those workers are getting older and retiring as the baby boomer bulge moves forward toward the end of the workforce demographic timeline. So with all of those factors at play, there's a pressure point, and the pressure point actually hits the industrial worker. We looked at this really interesting survey from Emergence Capital a couple of months ago, I should say. And Kevin Spain, one of the general partners at Emergence Capital, wrote about it in September. And what he talked about was that there's a 2.7 billion strong portion of the global workforce that actually doesn't sit at a desk. These are so-called deskless workers, and that they've largely been overlooked by the technology industry in terms of providing funding for and the creation of companies that meet the needs of industrial workers. So with that as the need for augmented reality, we also looked a bit at what the predictions are by research firms for how augmented reality is expected to develop. So this quote from ABI Research from October talks about their expectation of the development of the augmented reality market. And they expect it to reach $116 billion by 2023. And that revenue would be spread across devices, software, content, platforms, licensing, connectivity, and the other elements that are going to be needed to make it successful. So all of that brings us to the augmented reality management platform, which is what we were talking about earlier. So with all of those forces at play and wanting to enable and empower the industrial worker, what do you need in order to make that happen? So what we've developed is what we call a new category of enterprise software. And that is this augmented reality management platform. And it promises to provide every member of an industrial workforce with the relevant, contextual, personalized information and guidance from across the enterprise and the supply chain into their field of vision in a seamless, hands-free, and intuitive way. So how do we do that? Well, with augmented reality management platform, you need to have 8 key things. And I'm going to go through them quickly because I'm aware of time here. They need to be device agnostic, i.e. they need to be able to work on whatever devices are going to be useful to the industrial enterprise customer, whether that's smartphones, tablets, or smart glasses. They need to provide support for natural interactions. So those natural interactions would include gestures, they include head motion, they would include whatever touch support is provided on the device itself, and they would include voice. So you can imagine in industrial environments, each one of those being important. So if you're in an environment where it's actually quite noisy, you don't want to use voice as your primary method of input. If you're in an environment where people don't have their hands free, that they're actually working on things, and they're going to be using the devices to make calls to remote experts to get help, then you want them not to be able to have to use touch to provide input to the device. And if you want somebody to be able to quickly pan around a document, being able to use head motion, as you can actually in the latest version of our Athir management platform, you'll be able to do that without actually having to use your hands or your voice. So that support for natural interactions is really important. Then you need real-time collaboration, and that's all about being able to do see what I see video calls, being able to receive and use work instructions, and being able to have that kind of natural back and forth when you're collaborating with people, and have that enabled in remote use cases. You need also to be able to get access to the digital assets that are going to help you do your job, whether, as I said before, that's schematics, or it's digital photography, or it's video. Whatever you need to be able to do your job, the platform needs to be able to support. It also needs to be contextually aware. So one of the cool things about augmented reality is that it's delivered on mobile devices. And with a mobile device, you know where somebody is, you know what time it is. Based on their sign-in and their role, you have an idea of what they might be doing. And then if you layer on top of that information from the device itself, whether it's an IoT device or perhaps it's got a QR code on it, and you've scanned it, and you've got information about when the device was last serviced and what kinds of assets are needed to be able to do service and maintenance on it, then you have further context. And all of those things can be used to very quickly provide the person that's working on that piece of equipment with the information that they need to do their job. Concurrent with that is the idea of having a predictive experience. So being predictive means that you can take all the information about how people have used the work instructions before, what has happened with that particular device when it was last maintained, etc., to predict, well, what is going to be most useful next to the person who is doing this particular job. And what kinds of things do we need to be keeping an eye on and provide people alerts about. So you can imagine in a setting for a mine, for example, that you'd want to be able to feed people information about air quality and perhaps temperature and other environmental data that's going to be important to how they do their job and how safe they are doing their job. Then we get to the issue of performance analytics, and that was kind of what I referred to earlier, where you're looking at work instructions and business processes and how effective they are. Performance analytics allows you to see both at an individual level, at a group level, at a department level, across the company, or even across the company and its supply chain, how well the content that you're providing is performing and how well your collaboration tools are being used. And finally, of course, all of this has to be enterprise ready. So you need to be able to secure it. It needs to be reliable. It needs to be stable. It needs to integrate with the network infrastructure. It may need to integrate with ERP or LMS systems or any other major enterprise level systems where it's going to be able to collect and display data that's vital to what someone is doing and be able to feed data back. So all of those things are important. And all of this is actually outlined in detail in a white paper that we have, and you'll be getting links to that white paper following this event. So I'm going to switch now to talk a bit about the transportation and logistics industry itself. This is a huge industry. I mean, in the US alone, it totaled $1.4 trillion in business in 2016, and actually represented 8% of annual GDP. So it's a massive business covering everything from logistics services to freight rail to trucking to marine to express delivery services. We actually have also developed a white paper based on this, and you'll have access to that afterwards as well. The business issues that people in the transportation and logistics space are actually around 4 key areas. First of all, they're dealing with an evolving global economy. This evolving global economy it impacts a sector which actually is the lifeblood for moving the goods around the planet that create many economies. It's also increasingly complex, and people are employing a variety of technologies, including blockchain, to be able to track the movement of goods around the planet. And it has a heavier dependence than pretty much any other industry on having a well-maintained infrastructure. So, you know, you think about roads and railways and terminals and seaports. And finally, it's an industry where we're seeing a lot of automation of traditional tasks. All right. So I'm going to provide an example here now of drilling down into one of those transportation industry sectors, the trucking industry. So you've probably heard about some of the issues that the trucking industry is facing around not having enough drivers, and the measures that trucking companies have used to try and bring enough drivers into the trucking sector. But they're also facing issues around actually maintaining trucks and having experienced service technicians. So I've got a quote here. It's from our ebook around AR and transportation and logistics about the cost and complexity of maintaining vehicles and what the business impact of that is. And I'm going to move on in the interest of time here. But the impact of this particular problem is that if you've got a truck that's off the road, the company or person that owns it is actually not making any money. So if you've got a truck that is stuck for 3 to 5 days and it's got a full load, the trucking company has to send somebody else to pick up that load and then move it on. And then there are significant costs associated with that. So you can see very directly in that circumstance, if you're able to get somebody who can use the services of a remote expert and work instructions delivered to be able to more quickly get that truck back on the road, there's a very easily seen ROI. And speaking of ROI, I just wanted to give you an example from a company that we've worked with, Porsche Cars North America, where we have provided them with the technology for a solution that allows them to reduce significantly the service issue resolution times on their vehicles. They've seen a 40% reduction in service issue resolution times and are now rolling the solution out to 189 of their dealerships across North America. These are some of the things that we've learned, and we talked about some of this earlier. It's very high impact, and the ROI is easy to measure. Touch controls don't always do the job. You need multiple ways to interact, and it needs to be simple. I have some other learnings here, but I'm not going to go through them in detail because I believe we're going to make these slides available later. We also have a survey that we recently did, and you can see there's a really broad range of organizations that are involved in experimenting with AR right now. And the majority of them are expecting broad adoption within the next 3 years. And they're looking at them across a really wide range of use cases, including training, remote assessment and damage inspection, manufacturing, etc. And with that, I am going to pass it on to Martin.
Great, thank you so much, Jeff. Our
You're
next
welcome.
speaker we're going to be hearing about is cybersecurity risk and threats to the industrial environment. Dr. Martin Schwimmer is the manager and senior threat researcher at Trend Micro. Security of the IoT is currently at a similar level as IT security was about 20 years ago. What's worse is that modern networking and wireless technologies have exposed these insecure devices in unprecedented ways. In this talk, Dr. Schwimmer will explore some of Trend Micro's research findings over the past couple of years. These vulnerabilities are often in the basic design of these devices and their infrastructure. As examples, we will show how the insecure designs of the AIS wireless protocol allows for ship position spoofing. Train controllers are essentially hackable with a minimal investment. Furthermore, much of our critical infrastructure is left open to the internet for attack. Lastly, we will look into the future and why we think the security situation is going to get worse before it even gets better. And Martin Schwimmer was born in New York City, and he was raised there, and also in Hamburg, Germany. He eventually studied in both England and Germany, and it was at the University of Hamburg where he came to study computer security under Professor Brunstein. And in 1988, he co-founded the Virus Test Center, the first academic research center for malware. He started his first antivirus business in 1991, which is now part of Mqtt LLC. And in 1996, Martin joined IBM Research in New York to work with the IBM Antivirus Group and create the Digital Immune System, an automated malware analysis system capable of reacting faster to new malware than the malware could spread. The next switch was to IBM Research in Zurich, Switzerland, to research the applicability of intrusion detection techniques to the antivirus field, with one of the world's leading research groups in IDS and IPS. From this research, the DIMVA conference was formed. In this process, he got his first PhD with a thesis titled Malware Intrusion Detection. In 2007, he became an associate professor at CUNY's John Jay College of Criminal Justice, and in 2008, he joined Trend Micro, where he still works today. Martin has been a CARO member since its inception in 1990. He was a technical editor at Virus Bulletin from 2003 until 2013. In the past, he's contributed to various journals and books, either as guest editor or as author. He is currently focused on the application of AI in the field of threat data processing, as well as future threats to the industry. Please allow me to introduce Dr. Martin Schwimmer.
Yeah, thank you, Greg. And thank you everybody for being here. This is going to be a little bit of a shift of gears or so from the last talk, which I thought was great, by the way. Let's see, can I control my slides?
That's it.
Yes, I can. Look at that. Okay, so that shouldn't have been there. Oh, these are old slides. All right, look at that. So I'm in a part of Trend Micro called Trend Micro Research, and the specific group I'm in is FTR, where we're specifically interested in looking into the future of threats, future of crime, and things like that, we kind of split our tasks into investigation and hunting. We look at threat intelligence, but we also do technology research, which is what my kind of sub part of the FTR team is mainly dealing with or so. So when we look at threats, we're looking at from 3 different points of view. We're looking at it from the social research part of it. So how do changes in the way people interact and people work with work in their daily lives so change? Like for instance, in the previous example with AR, how would AR impact security? Because it's a different way of interacting. We also look at technology, how technology is changing, and that changes the threat landscape. But of course, we also need to look at the criminal underground, and so we look at these 3 aspects when we look at cybercrime. So, just as an example, a colleague of mine came to me because he was going to buy himself a new car. His car was getting old, and he was looking at the Skoda Fabia, which doesn't exist in the States, but if you're in Europe, you've probably seen them before. And he noticed when he was looking through the list of options that they were offering something called the SmartGate, and the SmartGate turned out to be a little module. It's like on the right side of the slide here, a little module that plugs into the CAN bus. It sits underneath the seat, and it basically delivers a Wi-Fi access point in that car. And he was wondering, okay, what can it actually do? And this was considered, a major advance in technology back in 2015 when we were looking at this. So how does it work? Well, it turned out, we discovered this very quickly, that the SmartGate password was just the VIN number of the car. So can we guess it? Yeah, I think we can. This is kind of how we approach the problem. And this gives you an idea how malicious adversarials will also approach security problems in general. So a VIN number is split up into a couple of different zones. You have the first couple of letters are the manufacturer. Then somewhere in there is also the make of the actual model of the car, and then there is also a factory code there somewhere. That's usually something that that the manufacturer will define, and then there's the chassis number, and then a couple other digits. Well, it turns out that we were looking at the Skoda Fabia, so we already know 2 pieces of information off the bat. A little bit of research told us that there only was one factory that that these were actually made in. So that gives us now a total of 6 digits that are fixed. We then noticed that the chassis number is actually a part of the SSID that was broadcast by the wireless access point. So we also had those digits as well. That only left us with 5 digits left. And that's actually a quite large search space, if you really want to brute force it. So we thought, well, there must be some way of making that a little bit easier. And it turns out that those last digits describe the car configuration. Well, we can look into the catalog from Skoda and discover, well, there really aren't that many combinations of configurations for that car. It's a low-end car. They don't really offer it with that many options. So we were able to reduce what looked like a very big problem, 10,000 different options, to more like, actually it's more than 10,000, sorry, but it's quite many tens of thousands, down to less than 1,000 we determined in the end. So that was that gave us right, yeah, these are the older slides. So so what you're not seeing here is well, I'm just gonna leave this slide up here. Sorry about this, guys. So what we're not seeing here is what we did was we started out in finding a car that actually had it. We then, oh, okay, we're gonna get the other slides.
Yes.
Great. Well, I'll continue to tell the story. So we got a laptop into a chase car. We found the Skoda Fabia with that option included. Obviously, we knew the owner of that car, so this was not something that we were doing without their permission. And while we were driving, we were actually able to get the brute force password guesser to find the password. And then when the slides come up, you'll see from the chase car, we were able to read out the through the app that Skoda provides. That will be slide 11. We were able to read out the parameters that the car was transmitting. In fact, actually, it transmits more than the app actually. Let me see. Can I control this now? Yeah, there we go.
Yep, do it.
And there we go. Okay, so on the left side, you see what we saw in the chase car. On the right side, you can see the app the way we saw it from inside the Skoda. And you can see there basically it's the same basic information, just different versions of the app. I think one was Android, one was iPhone. I forget the details. It's been a while. But the point of this was we were able to, with fairly limited amount of insider information, to actually read out this sort of information. So this worked, scarily enough, we feel that, that it's connected to the connecting it to the CAN bus does offer like a little bit of a danger here. We couldn't in all of our research find any way to get this little box to actually write to the CAN bus. That would have been very worrying. We also took some time, got one of the boxes off eBay, I think, and completely reverse engineered it. And they actually did a fairly good job in securing the hardware. So kudos to them. Is just the design flaw was mainly in the software. Why create the password as the VIN number? They could have done this a lot better. But when we do this sort of thing, finding the vulnerability itself isn't really enough. We need to figure out, there must be some reason for doing an attack. And in the Skoda example we just saw, we have to ask ourselves the question, well, why would an attacker, use this vulnerability that we found? And this is why we also look into the computer underground. And we look at the computer underground from, or e-crime from 3 different angles. We look at the money and the personal and the political angle that they seem to take. And these are very, very broad categories. Money is actually the easiest one here. So really early on in security, and as Greg mentioned before, I've been around for a while, but basically up to the early 2000s, criminals hadn't really figured out how to monetize off these attacks. But starting from the early 2000s, this changed, and they found more and more ways of profiting from attacks and vulnerabilities. And this is probably the most common motivator for crime on the internet nowadays. It's also the most predictable, though, which is nice, because the money has to end somewhere. And so when we're analyzing these sort of things, it's often, okay, where does the buck stop? It's also a lot easier to shut them down, relatively speaking, because law enforcement, and we do work with them a lot, is able to do things we can't do, and trace the money and then find the actual perpetrators. But it's also a little bit like whack-a-mole. You find somebody, you take them down, and another one comes up. And this can take, and since it can take years and years to work with law enforcement, this sometimes takes a while. Or this was not really very efficient way of dealing with the perpetrators. So as an example, and we do work with a lot of agencies here. Something that happened very recently, we were involved in a case where Ruslan Bandar was operating a malicious, well, not really malicious, well, yeah, kind of a malicious website that other criminals would actually use. We finally, after many years or so, managed to the FBI managed to find him, or the judges would found him guilty just earlier this year. This was after he was arrested in Latvia in 2017. And by the way, this is a pro tip for anybody in criminals out there. Don't go to a country after you've been indicted that has extradition to the United States. This is just a pro tip for you. He was indicted already in 2016. But we've actually been tracking this group since 2012. It's finally this year we're actually able to talk about this case. And you can see by this example how long these things take. So from 2012 all the way to 2018, that's how long these cases actually can last. So keep this in mind, and keep this in mind that it's also like a bit of a side gig for us as well. It's as a part of our data processing, we often find this sort of thing. So the other motivation is personal. This is the hardest thing to deal with, because these are very isolated actors. They usually know what they're doing, but their motivations are sort of unclear. Could be revenge, could be hacktivism, could be some sort of prank. And their activity is very limited in scope and time. And so a lot of these things go unnoticed by us. We see them in form of like doxing. We'll see that sometimes in the as a result in Pastebin. We'll see somebody dox somebody else, and so they post up there. But often we just don't see this sort of action. What is far more interesting for us, I guess, is a political motivation. Where we see obviously a lot of espionage going on. Teams will infiltrate their victims. They'll find data of value for their purposes. And this could be like military targets, political targets. This could also be industrial espionage. It happens quite a bit, and we can see this in our data, which is always very interesting. That sabotage is also a big thing. We make a big thing out of the dangers to critical infrastructure, and those are very real. And we have some papers on it. I'll mention those later. But in 2016, we already saw the political damage that can be caused, by groups such as these. And obviously, the espionage part can also lead to the sabotage, sometimes just by exposing people's details. These guys are often very persistent, very, very persistent. They're in it for the long run. And they're also very well funded to make this actually happen. What's odd is that they're OPSEC. That's we call OPSEC. Well, OPSEC is the operational security. It can be really variable. So sometimes they're extremely good, and then other times they're extremely bad. It's very odd. So it's like they invite some rookies over, train them up, and the rookies do stupid mistakes like not going on the Tor network for doing the next attack. But in general, these guys are on the whole pretty effective and pretty professional, and for that reason they're also very hard to defend against. They often will. These are the ones who often will use 0 days in their attacks, which are just by the nature of the game something that we just can't know about. So an example of this is PawnStorm, and we have some papers on it, so I'm not going to go into these in any great detail. This is also known as APT28. Some people know it under that that name. This is a very professional outfit that has been in operation for a very long time. I think the earliest we've been able to trace it to was like 2004 or something like that. That's even earlier than our team has been around. They will basically attack, targets in the U.S. and Western Europe if they feel that they can further Russian interests, and they'll pretty much adapt to any scenario that they feel would further their interests. So it's these are pretty nasty people to get entangled with. As I said, there are a lot more details in the papers. I would strongly recommend reading at least one of these papers. I mean, it's always very interesting reading. But it's hard at the outset to figure out what you're actually dealing with. It's only really after you get to know their methods that you can make some sort of determination, what sort of actor you're talking about. Is this like somebody out for revenge? Is this a criminal gang? Or maybe it's also a political actor. And of course, the best threat actors will muddy the waters by making their tools available outside of their scope of operation, so that we get confused and think that, well, maybe we're dealing with a criminal gang, whereas we actually are dealing with a political gang. So they can do that sort of thing. And they often are very willing to accept collateral damage, which I always kind of find is odd, but happens quite often. And an example of this is what happened to the shipping company Müller-Maersk last year. They were hit pretty badly by the Mqtt virus, or malware, I should say. And this was basically a combination of Eternal Blue, which is one of the tools that was released from the NSA, and Mqtt, which is a tool that a computer security researcher had released. And they combined the two into a very, very, very effective worm. And it affected the back-end systems of Maersk. And some estimates say that about $300 million was caused just to Maersk, and about 10 billion was caused by this worldwide. And the odd thing about it was, after some analysis, it was obvious that this was aimed at the Ukraine, not at Maersk at all. Had nothing to do with Maersk. But Maersk was collateral damage in this case that the attackers using this malware were willing to accept. My personal theory is that, in fact, the estimates are probably higher than what has been stated, because they hit so much of the supply chain, the worldwide supply chain, that there are surely knock-on effects that have just not been calculated into those equations. So I'm going to talk now more specifically about IIoT insecurity and look at some of the specific problems that we see. So it's kind of charming. IoT was created in a different era, a more innocent era, a bit like the internet, maybe 30 years ago. And even if the deployment of this technology seems to be fairly recent, a lot of the standards that it's based on are actually quite old, or rooted in eras that that had different assumptions. One of the assumptions is that if something's really hard to develop, it must be really hard to break. And that's, for instance, if you create like a wireless protocol, and we'll look into one in a moment, that would require, let's say in the 90s still, very fine-tuned filters and logic chips and other stuff that would cost a lot to develop and probably cost thousands to buy. But of course, nowadays you can just do this in software-defined radio. The other assumption that is often made is that these systems would only exist on in isolated networks or an isolated field, and not have any contact with the rest of the world. And unfortunately, that's no longer really the case. Modern requirements, and we all, again, I think Jeff mentioned this before as well. There is a need to be able to access these machines from remote, and so these things tend to get exposed where they weren't really designed for that. An example of this is the AIS system, which is the ship positioning system that was designed in the 1990s and mandated from 2002 onwards for ships larger than 300 tons. You can notice that I actually live next to a big harbor, so these things kind of come to me through osmosis. This basically allows things like ships, obviously, but also navigational aids and distress signals, for instance, from life vests, weather reports, all these things to be communicated over this basic wireless technology. And it can be used both ship to ship as well as ship to land, or land to ship, actually, in many cases. There's also websites like Marine Traffic or Vessel Tracker and things like that that will collect a lot of that information. It turns out, though, just to receive the signals, all we really need is this dongle for US dollars 22, $22 US or so. That's the investment you need to actually receive the signals, and then I can go out to the river, which is like just down the road from me here, and I can just listen in on all the signals that the ships are transmitting. This thing was meant to be a digital TV receiver. However, because they were lazy and they felt, why go through a lot of effort, they made it actually out of a software-defined radio chip, which means that the chip can be programmed to do pretty much anything in radio. And that's what we did. We actually reprogrammed the chip that's inside this little dongle to be able to receive the AIS signal. And that's kind of cool. You can receive the signals, but what you really want to do as a hacker is to actually modify the signals. And that surely must be harder, but it's not. It does require a little bit more upmarket material, but for about $100 to $300, you can get kit that will allow you to also transmit the AIS signal. And it turns out when we're looking at this that the signal really doesn't have any authentication in it at all. This is a design thing. There's no authentication, there's no integrity in the signals, so anybody basically can transmit whatever they want on these signals. And that was the design choice that they had made, assuming that nobody except for people really in the know would actually want to operate such a device. So we tried a couple of things like spoofing a land receiver, obviously in a protected environment. Instead of antennas, we use coax cables and stuff like that. And we also ran some other experiments. One of the things we tried was, so we have these marine tracking websites that allow people to track ships. Often if they're interested in cargo, they want to know where the cargo happens to be at this moment in time. And it's actually pretty easy to spoof the traffic from these AIS devices to these websites. So in this case, we pretended that we were a small yacht or some off the coast of the Adria, and kind of spelled out something on the screen. You can see it there. We basically pwned their site. Obviously, the ship didn't move, but the signal that we were transmitting pretended that the ship was in motion and spelled out, these words. And that was, I guess, moderately interesting. The other thing that we tried was spoofing the actual position to other ships. And obviously, we can't try that with real ships because these are safety devices. But we used the transmitter we showed before. We hooked it up to the coax cable. We took an actual AIS device and tried various experiments like, can we send out the signals so that it thinks that it's on a collision course with us, that sort of stuff. And yes, we could do pretty much anything. The other thing we discovered is we could actually shut down the AIS transmitter as well, because in the protocol they allowed for they allowed for an instruction to please change the channel. So if the AIS transmitter changed their channel, they no longer were broadcasting on a channel that most people were listening on. That's also an interesting attack against ships that we discovered. So the consequences are that the ships are becoming, ever more reliant on technology. And as a sailor myself, I mean, I catch myself, looking at the technology, looking at the GPS charts, and other things more than I probably should. But although I'd hope that most people would use other sources of information just to have just as a backup. But in practice, what we've seen is that for instance, the pirates started to use AIS. The pirates off the coast of Somalia started to use AIS to find ships to attack. So now many ships, when they get to that region, they actually turn off their AIS. And that's already kind of worrying. So that means a part of the world is not covered. What also happened last year was that the USS Fitzgerald, a frigate, was rammed by the container ship ACX Crystal. And what happened was the Crystal had changed course quite radically. We don't really know why, and didn't realize that the Fitzgerald was basically right there. And rammed the Fitzgerald from broadsides, and it turned out that the Fitzgerald was not actually running its AIS at all. It was completely off. We don't know why it was off, but it shows that the Crystal has just assumed that if you're a vehicle in that area, you're operating in that area, you'll have your AIS on, and they were not doing any plausibility checks there. So this is how we're getting more reliant on the technology. And AS is kind of symbolic for just not being designed with security in mind. There is no authentication, no integrity, but also no upgrade path. Once we find vulnerabilities like this, you would like to fix them, but there's no way of fixing them because there's no upgrade path for any of the technology. And you could say that, of course, hindsight is 20/20 vision, but we still see the same mistakes today in modern technology. And AS is really just the tip of the iceberg here. And we've been looking into legacy technology like pagers. Pagers are now finally being turned off in Japan next year, but they're still in use in critical infrastructure and also healthcare in the States. We looked at how robots can be affected with malware. We looked at how ITS, intelligent transport systems, can be vulnerable to various types of attacks, as well as smart cities, which are all becoming, more and more of an issue nowadays. So, whoop. I'm going the wrong direction. Sorry. This is what happens when you press the mouse in the wrong area. The other thing that we discovered while looking at some of this stuff is that a lot of these systems have a lot of unexpected connectivity in that they're connected to the internet and we don't know why they are. You may or may not be aware of Shodan. Let me just explain what it is. So Shodan is kind of like Google, but for IoT. It's a search engine that John Matherly operates that goes out and specifically goes out to find devices. It's you can search by port numbers that they're open on. You can look for names of operating systems, and in the IoT field, they often have very interesting and unique ones. So we can look for all sorts of interesting things on Shodan, and of course we do because we can, and also because since it's an open platform, other people will as well. So we better do it first. And we found, for instance, that that just looking at Shodan, no other form of data, but just looking at Shodan, we discovered that in United States cities alone, some of them are very vulnerable. Like Los Angeles, I hope that nobody's living in Los Angeles. Well, greetings to all the IoT out there. Los Angeles has like a lot of exposed devices in its infrastructure. New York, where I come from, a lot less, but still plenty to get me worried. And what's worse, nearly, is that the other thing we can find. Well, actually, all right, I'll go back to that in a moment. The problem, of course, with these public-facing technologies is that that no device can ever be secure. I mean, we now know that upgrading our machines or updating them is very, very important. It's crucial to our security. But and these IoT devices, are no exception there, and we're finding vulnerabilities in them constantly. But the problem is that these devices are rarely updated. In fact, sometimes they can't be updated. You have to go there physically and actually update them. So having these things exposed on the public internet is very worrying from our point of view. What's more is we also see other interesting aspects of IoT out there through Shodan as well. This is probably all through Shodan. So here we actually see the human interfaces to a lot of these systems, and where we can see not just that we could potentially control some of these, some of this IoT, in some cases these are water pumps or parts of logistics infrastructures. If we had the password, which are often easily guessable, we could control these things. But we also gain insight into what's actually happening inside that company or that site, and we wouldn't have had this without this sort of interface to it. So this is all quite worrying. And then it turns out that there are also a lot of protocols out there that have endpoints on the internet. One very popular one is Mqtt. And the timing of this talk is really great because this paper was literally released yesterday. So finally, I'm actually able to talk about it. Mqtt is a message brokering system for IoT, and there are a lot of installations out there that are fairly open. On top of that, both have security design flaws in them. that are not necessarily patched unless unless you really keep up to date with the installation. So what's going to happen in the future? Well, when I was visiting the Hannover Industriemesse, which is one of the world's largest industrial trade fairs, earlier this year, I noticed that a lot of the manufacturers are advertising the fact that their equipment is now connected to 4G in this case. And the reason for this, is yes, so that the manufacturer can make sure that the equipment stays healthy, and so that they can also do preemptive maintenance on it, and therefore have better customer service. Make sure there's no downtime on it. All really great ideas. And on top of that, a lot of these systems have their management in the cloud somewhere as well, which means that even if you can't get at the actual machine itself, you can get at the cloud infrastructure, a little bit like the HMIs we just saw before, or the Mqtt endpoints we saw before. So in theory, this is all great, but yes, it means that this equipment is also more exposed than it ever was before. And what's worse is that we're also seeing now new forms of connectivity. So 5G, which is starting to be rolled out over the world, is bringing in NB-IoT, so narrowband IoT. And there's also another competition to that, a competing standard called LoRaWAN. Both of these can be used to monitor or collect data from these devices. And yet, there's very little security talk. So one thing they didn't talk about when they're talking about 4G was, well, how they're actually securing these devices. And so I'd like you to keep in mind that the examples I've been giving are really just more symbolic. There's a lot more stuff underneath the tip of the iceberg there, and even if you don't run your own shipping, and you don't have AI systems in operation, that doesn't mean that some other system, some other telemetry system in your truck or in your factory won't have similar sorts of issues in it. And I don't really want to scare you, and that's definitely not my intention, but it's something to keep in mind when implementing security. Everything that I've been talking about are in papers. There are 2 links here, and I believe Greg and Lucian will be sending out links to the actual papers directly, so you can find them. And with that, I'd like to thank you for your attention, and hope you're doing fine out there.
Thank you, Dr. Martin Schwimmer. And if that didn't scare you, I tell you it scared me. But the good news is that the next couple of presentation will be focused on providing some solutions towards this. So the first, we're going to be hearing from not a colleague from Trend, a colleague of Morton from Trend Micro, and this will be Mr. William Cam, the technical product manager at Trend Micro. The presentation will provide an overview of Trend Micro cybersecurity solution for the operational technology domain. William will also explain how Trend Micro adheres to the industry standard reference architecture established by the International Society of Automation, ISA. By following ISA 95 reference architecture guidelines, it shows ICS professionals that have followed this model to start their deployments more easily. This presentation will help you understand how to deploy a Trend Micro recommended solution. For those of you who may not be aware, William has been with Trend Micro since 2001, and his current responsibility as technical product marketing for Trend Micro cybersecurity solutions for the operational technology domain, specifically for the industrial control system for oil and natural gas, power and energy, manufacturing, healthcare, and retail. With that, William, the floor is yours.
Okay. Good morning or good afternoon. Let me try and get control here. Okay, I think I have control.
Just one moment to make sure that that's happening. Here we go.
Okay, my name is William Cam, and I've been at Trend Micro for quite a number of years, and we'll be focusing on Trend Micro cybersecurity solutions for the operational technology domain, with specific focusing on the industrial control systems. Yeah, a common question when we talk to people is how does Trend Micro determine, what our cybersecurity solutions are, or what our reaction is to the events in the industry. So you can see that from the previous presentation that we have quite a large number of threat researchers. They're basically, forward-looking technologies. They work in conjunction with our product management and our developers, and we come up with solutions to, combat the existing threats, but also be looking forward. And a lot of times it's a gamble, and hopefully you're successful in your threat research and be able to understand, what these guys are doing, where we think they'll be going, and trying to come up with a solution that can combat these guys. And that's what I'm going to talk about. So this will be our agenda. Trend Micro provides a number of supporting materials such as white papers, data sheets, reference architectures that we focus on. And this is a list of the cybersecurity solutions for the operational technology domain. We will present some of these solutions later on. I can't do all of these due to time, but I'll take out the most specific ones that are focusing on the industrial control systems, which will piggyback on what was done by our threat researcher in the previous slide presentation. These are the 5 areas that I'm particularly focusing on the U.S. And not to exclude things of smart vehicles, smart cities, smart devices, cameras, routers, etc., or other activities that is being supported by different business units. So if you have an interest outside these areas that we're not discussing today, we can always get you in contact with the correct resources. So as mentioned before, the Trend Micro is a active and participating member of the biweekly meetings for the ISA, Instrumentation Society of Automation. Trend Micro adheres to standards in general, and where there are no standards, we try to go it alone. If we come up with some technologies, we try to promote these to the industry. We work with a lot of consortiums, even work with our competitors in discussing, what is happening in the industry, so we can all be, be forward-looking and coming up with solutions that can solve the customer's business problem. And so for our cybersecurity solutions, we've adopted the ISA 95 reference architecture model for deploying our cybersecurity solutions. And here's our basic model. If you're not aware, Trend Micro has been in the industry for like 30 years. I think this is our 30th year. So if you look at the right side of the diagram here, we've been in the IT information technology for 30 years. We've been deploying solutions, and the information technology is considered to be a 3-layer model, which is the gateway. You have your middleware, and you have your endpoints. The Trend Micro is pretty successful right here. If you go to abtest.org, they test products on a regular basis, and you can see that Trend Micro tries to maintain a profile of being top 3. Can't always be top 1, but our model is to be at least be the top 3 vendors for cybersecurity solutions. And when you look at the left part of the screen, this is our operational technology. We're not new to this industry. We've been, that Japan is a powerhouse for the industrialization, cars, etc. And we have been working in that industry with our Japan marketing for a large number of years. And I would say that, for the last 5 years, we've been, focusing on this within our U.S. market right here. And when you look at the OT domain, it's a layered architecture, and it's based on the ISA 95, which starts as a 4-layer model. And you can see with the 4-layer model here, we've broken down the control layer to be the instrumentation and then the process control, but it is a 4-layer model. And what we'll do in the subsequent slides is we'll be focusing on some of the cybersecurity solutions for our control layer, which is for instrumentation or the process control. So for level 0, which is the bottom layer, which is made up of the devices, the actuators, essentials, and the embedded devices, Trend Micro supports this level of activity with our Trend Micro IoT security. It's a precompiled set of binaries that runs for the Linux, Unix, and real-time operating system. So at that level, we're seeing some Windows, but really a move to I don't know what they're saying, but a more secure type of environment or more a controllable type of environment. So although Windows is still there, we see a large growth of everything being outside Windows. And if you're aware, Microsoft is recognizing that Linux is a important operating system, and if you look at the Azure system, they actually support. For level 1, the instrumentation and process control layers, Trend Micro has a flagship lockdown or whitelisting application called SafeLock. This application is specifically designed and implemented for the industrial control system. It's not a port of or migration of the application control that you see in the information technology domain. This behavior are quite different, and therefore we decided that we were going to specifically design an application for the industrial control systems. And for level 3, the level, Trend Micro provides the best-of-breed solutions that protects the network layer for our with our next-generation IPS tipping point and superior sandboxing technology with Trend Micro's deep discovery products. And then finally, with our Trend Micro Deep Security, we provide protection for virtual cloud systems and environments that are running Windows and Linux type systems. So this will be our portfolio suite. I'll focus on the edge server and middleware layers from this diagram. Okay, so Trend Micro's SafeLock product, it's a whitelisting solution specifically designed for such machines as HMI machines, ATMs, point of sales, kiosks, and embedded systems, and the likes. This cybersecurity solution is exactly the opposite of what you're running on your day-to-day laptops or office machines, where those machines need to, periodically connect to the internet to either to download a pattern file and or to do cloud-based replication. There'll be a on-demand scan, and when you access any kind of a file, there'll be a real-time scan, and periodically, if you're connected to your IT environment, they control the, they'll schedule a scan periodically. This SafeLock product, it doesn't do any of that kind of behavior. It's a whitelisting solution, so when you install the software on the product, it does assessment and services assessment. It figures out what's running on the machine, and it will lock down the machine upon the completion of the assessment. And therefore, any kind of a malware or activity, external activity that's injected after the fact, if it's not on the approved list, it will not be able to run and will be stopped. So the 3 benefits for the SafeLock product is that since it's not doing any of the things you normally see on your business applications, it'll have a minimum impact on the performance, and I'll show you a slide a little later on. It implements exploit protection to prevent malicious injection of activities, and we can say it's has forward-looking technologies, because if you're not on the list, you're not going to be able to run. So we can say that anything coming down the pipe, in most cases we should be able to block that kind of activities, and we also focus on a ease of operation. We support 2 modes of operation. Basically, this product was born around the air-gapped environment. So you have a standalone agent, you install on the machine, and you can run it and it locks down the machine. As we've seen over the years, even the air-gapped machines are slowly emerging to being put on the internet. Some of it is for gathering, statistics, so upper-level management can make better business decisions. So we're seeing that kind of activity. But moreover, a lot of times on the factory floor, they have isolated networks and they have groups of machines of anywhere from 10, and in some cases we've seen 100 machines grouped in a local LAN. In that case right here, if you're installing SafeLock on a number of those machines, you could actually deploy a central management console that can administer those machines from a central side instead of having to go to each machine individually. So you can see, as the business model changes, we've also modified our products that we can take advantage of the growing developments within the factory environment. And as I mentioned before, Trend Micro deploys a layered defense, enterprise layer protection for the IT, and defense in depth for the OT domains, respectively. And as you can see right here, even at the product level, Trend Micro has a similar architecture where we have a layer protection. Whether you're at the infrastructure level, the application level, or even at the product level, we have a layer protection with the technologies that are addressing the attack vectors that we see coming out from the hackers. So to protect the devices, Trend Micro SafeLock agent, provides this level of protection to control like USB malware protection, network virus protection. The network virus protection would be for your older systems like your XP and your Windows 2K systems. So since most of this stuff is locked down, there's now been developing a new vector of attack, which is called fileless attack protection. And SafeLock recently added this feature as an emerging source for the latest types of attacks. And what we can do is that we can monitor all the processes, the process chain, the command line arguments associated with the fileless attack. And this is usually coming from, PowerShell and other kind of scripting type activities that are, being done. So it's like when your contractor comes to the site, plugs in a USB sticks, and wants to run some maintenance kind of stuff, they can inject this type of activity. So we manage the events based on the last 5 parent processes involved in the process chain. We manage the events based on the command line arguments. And so the fileless attack prevention blocks all the execution of the targets by the processes by default. And as I mentioned, when you're looking at whitelisting versus blocklisting, we did some workload modeling. So you can see right here, there is a graph, but if you look at the left side of the graph, you can see that the performance X impact is like 0.002. So basically it has minimal impact on the system performance. As I mentioned before, you're not downloading pattern files, you're not doing cloud-based reputations, you're not running any real-time scans, on-demand scan, or scheduled scan on the machine. What it will do is every time that an image is executed, it will check to see if that image is allowed to be run, and if it's on the approved list, it'll run, and so it has a minimal impact on the workload, which is critical when you're talking about industrial control systems, which are based on real-time defenses. As I mentioned, the micro products provide exploit protection and intrusion prevention when used with removable devices, such as USB, CD-ROMs. So you can control these devices. They have either read-write access, and we block the ability to access or run anything from a device or actually content on the physical machine. And as I mentioned before, I've discussed before, we recently added fileless attack prevention. So this is a part of the layer protection that we're including constantly as we see the environments changing from what's happening from our threat researchers. And as I mentioned, typically, it's air gap by nature. So we have a SafeLock agent. However, we're seeing the emergence of deployment of systems that are starting to have connectivity to the internet. But moreover, there's local LANs with groups of machines and tied together. And we're seeing the requests from our customers that, they'd like to centrally manage those machines. So what we do provide is an intelligent manager that can group them together and control the operations from a central location. So the intelligent manager would have the, the console, and it's also standalone agent. The second product I'd like to discuss is our Trend Micro Portable Security. Once again, we're really talking about air-gapped environment, and this is a USB stick. The use is that you plug this stick into a computer in your office, at home, or wherever you're at, and you can update the threat intelligence via the internet. You then would take this stick and walk it over to an air-gapped machine, plug it into your USB port on the machine, and you can scan the machine. And scans can take anywhere from 15 minutes, and they can take anywhere up to 4 hours. And you're talking about industrial control systems, so there's a lot of processes and information on the machine. So, the run times or the scan times can take quite a while. And as mentioned before, we're seeing the emergence of limited internet connection on the factory floor or the local LANs. So, like our SafeLock, our portable security, you can set up one of these devices to be what we call a management program, and it can that management program can talk to the internet, or you can set up a local intelligence server on the local LAN. Get the intelligence from there. It'll then bring it to the management console, and then it can distribute it to all of the endpoint devices that are running the portable security stick on the individual systems. So like the SafeLock product, the portable security supports a client-server mode of operation. And here's would be the operation. So you plug it into a system. You would do a scan. If there was no malware detected, the LED would be blue, and if there's a malware detected, the LED will be red. It has cleanup technologies, and if it cleans up successfully, you will see a yellow indicator. We also see this being used. I guess a lot of people have learned from the Ukraine attack. It escapes me what that incident was, but we see a lot of our vendors using this when a consultant will come into a company. We know that the consultant is using, some sort of a cybersecurity solution, but they want to ensure that this product is not infected. So what they'll do is that when the consultant is actually registering to get their badge, they'll actually plug this USB stick and scan the machine. And for a regular business office PC, like a laptop, it usually takes about, maybe like 10 minutes to be able to scan a machine. So, which is about the time it takes to, register at a company and wait for the host to come down and get the individual. So we see that kind of usage right there. So not just there for the industrial controls, but we see it broadening out to other areas for, cybersecurity protection. And that concludes my slide presentation, and I'll pass it over to the next presenter.
Thank you.
Thank you so much, William. Oh, sorry, Lucian. No, that was it's nice to know that there's actually something to mitigate some of the threats that we heard about earlier. So thank you for that. We're going to move on to our next presentation now. This is entitled Cyber Hardening Industrial IoT Assets for Continuity of Operations. And our speaker is Joe Saunders, and Joe is the CEO and founder of RunSafe Security. So this session, we're going to talk through how to prevent rather than detect an entire class of malware attacks, how to preclude exploits from executing and spreading, and how to protect software, embedded systems, and devices without providing access to source code. Joe, as I mentioned, is the founder and CEO of RunSafe Security. He has more than 25 years of leadership, business building, and startup experience. And he's served on a variety of business development and general management roles from high-growth companies. Prior to founding RunSafe Security, Joe served as director of Thomas Rutter's Special Services, where he led analytical solutions to help law enforcement agencies identify national security threats. Joe previously led the digital technology division of Ames worldwide, and was a member of the management team of Targus Info, which was acquired by Neustar for $750 million in 2011. Joe started his career as a consultant at PricewaterhouseCoopers, building quantitative models for financial institutions. Joe has a BS in mathematics from the University of Michigan and an MS in predictive analytics from Northwestern University. And on top of that, he also has an MBA from George Mason University. He's the founder of Children's Voice International, a 501c3 nonprofit that restores the rights of abandoned, neglected, trafficked, and exiled children worldwide. So please allow me to introduce Joe. Take it away, Joe.
Thank you very much, and it's a pleasure to be here. And I certainly agree with some of the kind of scary notions of Morton's symbolic kind of representation of attacks, and certainly some of the solutions that are out there. And from a run safe perspective, what I thought I would do is just kind of talk about a little bit how we got started, and then where we fit in terms of solving some of these security threats for operational technology, as well as industrial IoT and related systems. And so we are working with folks like Nutanix and Bosch, Avicent, ByteGrid, even Vertiv, which was formerly Emerson Network Power, in terms of protecting thermal management control boards across data centers and power plants and the like. But the company got its start actually out of a DARPA program when the Department of Defense asked us a question, which was, if you assume hardware in your supply chain has been compromised, how do you build trusted, secure software on top of untrusted hardware? And so, the approaches we take were kind of born out of that experience. And since that time, we have set out to protect critical infrastructure. So if you're thinking about smart manufacturing and industrial control systems, or IoT and industrial IoT systems, there's kind of a common theme that if your software is all the same, if it's logically the same, if it's deployed, the same versions across hundreds or thousands of devices globally, and if there's a vulnerability that, as was mentioned earlier, kind of constantly are being uncovered and discovered, it's very hard to kind of keep pace, whether to update those or issue patches and the like. And so we tried to think about this in a different way and eliminate a series of attacks or a whole class of attacks and take those off the table. So today our technology is protecting firmware, operating systems, applications, really across industries, but certainly part of our experience, not only in the transportation industry, but also in the kind of the industrial space writ large, has been that there are systems that get deployed that are out there for a long, long time. And if they are out there for a long, long time, and then security itself becomes a problem, because systems don't keep pace with the security trends that are happening. And so we actually see kind of three drivers that are increasing the threat, the security threats across industries. And one is certainly in the IT space in general, with the wide adoption of virtual machines and the virtualized technology. It's increasing the attack surface so that software across all enterprise IT systems and data centers have common vulnerabilities based on virtualization software. And then certainly in the supply chain, whether it's a smart manufacturing plant, or in the case of hardware compromises that occur in the supply chain itself, there can be vulnerabilities that are introduced early into the life cycle of a device, and that can be kind of exploited over time once it's out there, given all the connectivity that's out there. But then lastly, just kind of the driver of all these smart devices being connected to the internet is increasing the attack surfaces. And so with that, we kind of set out to find a way to resolve these kinds of threats in a way. I don't think I have control anymore, Lucian. There we go. And so we tried to find a way that would solve the kind of threats that these systems and these devices face. And what we realized was, there are a dramatic increase in malware attacks. As was mentioned earlier, there are a number of fileless attacks, and our data suggests that the 10 times more likely to have a fileless attack than traditional attacks, given the past year in looking at these kinds of devices. And then the attack on supply chains has increased dramatically over the past year or so, at least the reporting of that. And of course, the challenge there is, how do you make sense of all this complexity? You've got a proliferation of devices, you have an increase in attack surfaces, and you have a complex, sophisticated set of attack tools that are out there. So from a run-safe perspective, when we've looked across critical infrastructure, we've seen attacks of this very nature really across all industries. And whether it's in the transportation world or with automotive hacks that have been demonstrated, or attacks on logistics and transportation, or certainly attacks on PLCs and the like across oil and gas and different industries. All of these attacks have a common thing, and that is that there needs to be an approach that really focuses in on preventing such attacks as opposed to only detecting. Now, certainly there's a significantly positive role in detecting and having visibility across your network and knowing what's going on across all your assets, if you will. But there also is an increasing demand to actually eliminate at least some of the threats so that you can maintain a continuity of operations across these mission critical systems. So what we've done is we kind of answered the question of, if all software for a given industrial control or some kind of IoT device is identical from device to device, well then maybe we should add the hardening in a way that makes those devices less vulnerable to an attack that was identified in a lab, so that vulnerability built in the lab doesn't affect the fielded device that's out there. So RunSafe has built a solution called Alchemist. And what Alchemist does is it takes, whether it's legacy deployed software binaries or new software binaries that are getting deployed on hardware and shipped out into the field, we can take those software binaries and run it through our transformation engine. And without access to source code, without access to compilers, and without changing the functionality or adding software agents onto a device, we are applying binary hardening techniques, and they're listed there in the middle: binary randomization, control flow integrity, and stack frame randomization. I'll describe what each of those are in a minute. But if you apply this kind of transformation to unprotected software binaries, whether they're legacy systems or new systems, then you can eliminate an entire class of attacks that are born out of memory corruption errors, buffer overflows, and generally kind of zero-day exploits that take remote execution and control of systems by applying these hardening techniques. And so with that, what I thought I would do is kind of explain these techniques in a little bit of detail, and then talk through a couple examples of where it's deployed out in the field today. So I mentioned, this notion of hardening the software binaries. Some people call it binary scrambling. Some people, think about this as moving target defenses. And in our transformations at RunSafe through Alchemist, we're applying any of, three types of cyber hardening techniques or transformations. And, the first one, control flow integrity, that ensures that even if a bad actor gains access to a network, or an insider gains access to a system and wants to, apply an exploit on a target system, what it means is they can't resort functions into a new sequence. They can only, the software will only execute functions in the order in which they were intended. And often with, ROP gadgets, what an attacker is trying to do, rather than having the sequence of the legitimate functions be executed in the normal sequence, 1, 2, 3, 4, 5, they may choose just function 2 and just function 5. And the combination of those two attacks leads to something malicious. So we harden against that kind of manipulation of legitimate code using what we call control flow integrity. And then we also apply, something called basic block randomization, which, rewrites a software binary in such a way that on each device, the location in memory where basic block functions get executed will change. And so what a hacker needs is a deterministic view of where in memory to go and grab a function or take control. And if each device is functionally identical but logically unique, then you can see how an attack or a vulnerability that's identified in the lab may not be vulnerable if basic block randomization is applied to a device in the field. And then the third one is really a runtime defense that prevents an attacker from jumping into the software stack and manipulating things to their advantage. And so we add a layer of randomization to the software stack as well. And all of this is done without really compromising the overhead or the performance of the system. So like I said, part of the idea here is to prevent attacks. And if you think about a bad actor, just like every other business, if you will, oftentimes they're looking to build an exploit tool. Maybe they want to sell it on the dark web. Maybe they want to, apply it across 3,000 IoT devices. Maybe they want to, take out many servers in a data center, kind of simultaneously, or maybe they want to knock out many actuators, across, kind of an ecosystem, if you will. And this kind of approach prevents the scaling of that single exploit, administering that malicious behavior across multiple devices. Why? Because with the cyber hardening techniques added, the attack can't propagate from device to device, if you will. And certainly the fileless attacks are rendered inert, using these same techniques. So with that, I thought I would share a couple examples of companies that have deployed this technology so you can get a feel for how it's being used. I mentioned early on that we're working with Vertiv, and Vertiv has a thermal management control board as well as sensors that are deployed across infrastructure, whether it's a nuclear facility or a data center, or a power plant, or even weapon systems that require cooling, so that they can be administered out in a kind of in theater or fielded systems. What Vertiv does not want to be is the weak link in the infrastructure, and so they also kind of looked at it and said there's no way we can administer or monitor fielded devices and just react to alerts, that adds some effort to their customers who are deploying their technology. So by adding cyber hardening to the sensors, to the control boards, they are no longer the weak link in the infrastructure and certainly providing a layer of protection for their customers. So there's hundreds of thousands of devices deployed by Vertiv with this kind of protection. And then in the automotive space, I mentioned Bosch earlier in their automotive division, ATOS, and certainly Lear here, both have similar kinds of use cases, whether they want to protect the embedded software on the automobile or protect the telematics system and or the GPS navigation system. You can imagine if someone were to hack the navigation system or the GPS, that can kind of wreak havoc both on the efficiency of logistics and distribution, or it certainly could steer an autonomous vehicle's decision making off course, if you will. And so in both cases where public safety is an issue, they wanted to protect against the remote control and execution or the administration of an exploit that could be otherwise deployed onto a telematics platform or GPS. And so in general, across IP or IoT or even OT systems, these kinds of techniques are very relevant, ways to easily deploy both for legacy systems and for new products that are shipped. So with that, because, we're big fans of what IIoT World is doing, we certainly want to kind of share, kind of the benefits that they offer us by offering their community. If anybody does have an interest in an assessment of whether these transforms would work on their software binaries, happy to help that. Or if you just want to reach out, directly and talk about some of these things, certainly happy to do that. But I'll just kind of leave it on the final note that our mascot there, Bugsy, is a software bug who's tired of vulnerable software code being constantly exploited. So much like RunSafe, he's trying to transform cybersecurity into a protected version of the same. So thank you, everyone, and look forward to the questions.
Outstanding. Well, thank you for an enlightening presentation. It's definitely been, for myself, at least, it's been enlightening, Joe, and all the other panelists. And we will try not to disappoint Bugsy. So let's move into some of the questions that have come in. I've got one here. It looks like it is tabled at you, Jeff. It says, what would you say is the biggest barrier to adoption for enterprises looking to adopt augmented reality?
Well, that's a good question. And in fact, it was one of the things that I covered in the last part of the slides. We actually did a survey earlier this year where we talked to a lot of enterprises about what they see as their biggest challenges in terms of adoption. The three things that came up were lack of clarity about return on investment, the hardware limitations, and the lack of understanding about where augmented reality could best be used. So those are all kind of symptoms of the fact that it's a very young industry, and that people could use a lot more information about how it can make a difference in their business.
Excellent. Well, thank you. I got another one here. It says, how is the IT industry preparing for the 5th generation of cyber attacks? And they give an example of possible adoption of fail-safe systems. This was coming to us from Nexus Integral out of Texas. Would anyone care to take a shot at that one?
William Cam here. I think we mentioned this at the beginning of my presentation, is that, for Trend Micro, we have, a lot of threat researchers. They're doing a lot of forward-looking activity, and the threat researchers in conjunction with our product management and developers, we kind of come up with solutions that we think will happen based on, the current activities and what we foresee as the projected activities from, the cyber activities in the industry.
Okay. Thank you, William. I had a series of questions come in from Sumit also. So in today's IoT for manufacturing, is DMZ a need to have or a nice to have?
Yeah, and the next question is, SafeLock whitelisting is a substitute for additional firewall layers between layers 2 and 3. I'm going to answer these two questions by referring to this this diagram right here, and I'm going to kind of give you, I'm going to answer this with a scenario that happened in around 2015. Basically, when we talk to the industries on slide number 3, the 5 areas of manufacturing that we work in, I would say that almost 100% of everybody has a firewall that separates the IT from the OT domain. So that's about a given rate. That's their level of protection from the OT. And usually the IT lead and the OT lead, they really don't talk to each other. Tradition's been kind of combative, but I guess going forward, we're seeing a little bit of merger right here. So basically, in 2015, there was an attack on the Ukraine power grid, and basically this was the basic architecture. There was the IT side and there was the OT side separated by a firewall. And what happens is a little piece of malware came into the IT domain. The enemy clicked on it, and he actually launched the malware in the IT side. The malware was intelligent enough to probe around. It found the firewall between the IT and the OT. It actually jumped the firewall and got into the supervisor layer of the OT domain. It sat around there for quite a number of weeks, collecting information, passwords, architecture, and then it found out that between the different layers, there were VPNs with theoretically 2-factor authentication to get to the next layer. So what it did is that it then jumped the layers, got into the process control, set the or turned off the breakers, shut down the power, and then it did a denial of service against the call center. So everybody that had the power outages couldn't call in. So it was a catastrophe over there, and it actually attacked 3 substations. So it was quite massive. And so from the outcrop of that, the industry has learned that the single firewall separating the IT and the OT domain is not good enough. So it really depends on your business requirements for security. So actually, what we've seen in some cases is that at the separating the supervisor control layer, we've seen a firewall. We've actually had customers taking the tipping point and the deep discovery that you see in the supervisor level. And for every layer that they deploy a firewall, so there was a firewall separating the control and the supervisor on the inside of the firewall. We also saw a tipping point in deep discovery. We also saw somebody deploying a firewall between the control layers, the implementation and the process control. And then we also saw them deploying firewalls separating the actuators, sensors, and device layers. So we've seen, like a kind of a knee-jerk reaction where they've actually added a lot more security at the different layers. So you could say that some cases, people are reacting differently by deploying, different technologies for the different layers. So that's a worst case area we've seen. So we did see that. So basically, as I mentioned before, is that the SafeLock is really designed for, it's a Windows-based system. So it's really designed for the implementation layer of the control layer. And typically the process control layer is usually, real-time OSs or Unix or something like that. And for that environment, we have our, as I mentioned before, we have our IIoT security. It supplies the same whitelisting application. It also supplies vulnerability protection. It has network anomaly behaviors, and it also has HIP-type capabilities for the process control and the sensory layers. Last question is would SafeLock configuration be done on the Trend Micro server, which we deployed in the DMZ, which is the preferred layer? Well, the answer is that you can deploy a server on there that can help you, manage the agents that are deployed in that environment. But the basic model for deploying this is that somewhere probably in the IT area or in the supervisor layer is you'll be having a, POC area or a benchmarking software deployment area. So in that environment right there is what you would do is you would then set up the machines, load the software, stage everything there, and then install SafeLock. And once that assessment is done, then you would then deploy those solutions within the process control or instrumentation layer. You wouldn't typically be running those assessments at those environments, because what they do is they can take some 4 or 5 hours depending on the number of applications. And we've seen some where there's 20,000 executables within the environment, and that'll take quite a while to build the whitelisting. So that'll be staged offsite and then moved to the factory floor. And so the question is that now I have my application staged in the factory floor, and I either have a security update or I have an application update. What are you going to do? Am I going to go in there and shut that machine down and then do this assessment? The answer is no. What you can do in your staging environment, so let's just say you have this environment here, or an ATM machine that disperses money in a bank. What you can do is that you can, at the staging site, which has the same software to be deployed in the runnable environment, you can apply the security patches and the services, and then you can, do a reassessment and create the whitelisting for the patch or the software. And then when you go with the running environment, what you would do is you would just import the new approved list, add it to the system, then you can install the binaries, and then you're off and running. So basically, you're going to be installing a approved list of new binaries that'll be running. So you'll have minimal impact on doing an upgrade on the system. So that's how the SafeLock product would work. Any questions?
No, that was a good explanation. Thank you very much. We did have another question came in, and this was for RunSafe. It says, how challenging is it to transform firmware with RunSafe, and what's the process? This is coming in from William.
Thank you, William. Yeah, it's actually very straightforward. So Alchemist is an easy to deploy tool, and that can be deployed within the DevOps environment. for people that are doing build of equipment and put that out there, or it can be inserted, in the assembly process at the hardware manufacturer, if you will, quite easily as well. So very simple and straightforward. The process is there's an API, you identify your firmware, you access the API and you identify where your firmware resides, and in seconds or minutes, that firmware will be transformed, and then you can get the protected version right out of it. So it's a simple API. It's very straightforward to do, and it's delivered in a very secure way.
Excellent, thank you. Another question for Joe. Says, what is the biggest misconception that professionals in the transportation and the logistics industries have about predicting their networks, or protecting their networks, and devices from cyber attacks?
Well, I like the idea that having good threat intelligence is very helpful, and you can get a good feel for where your threats are maybe going or where they're coming from. But I do think that a lot of people are focused in on maybe detection more than prevention. And so certainly from our perspective, we're a firm believer that adding a layer of prevention and eliminating an entire class is a good use of resources. And so I think there's one misconception that which is that I need total visibility of all my threats and all my potential attacks and all the things that could be going wrong. And whereas if you compare that to simply adding layers of defenses like was discussed earlier, but also thinking about it from a prevention perspective. So cybersecurity for legacy systems, I'd say kind of a close second. For legacy deployed systems, does not have to be simply an alternative to rip and replace equipment. You can apply security to existing legacy systems that have been around quite a while as well, and maintain that investment in those products that are out there. So I kind of hit it from two angles. One is prevention, and two is you can certainly provide layers of protection through cybersecurity protection for legacy systems.
Excellent. Okay, another one that came in is, with the advent of IoT, can secure protocols be utilized or self-correcting systems be created to protect private data? I'll throw that out to the panel.
That's a very strange question. So self-correcting systems don't really exist in that in the form that I would like to see them existing yet. I don't know whether somebody else has a different perspective on that.
Yeah, I would say that there's been some simulations through DARPA around kind of self-correcting, self-healing. So they administer kind of a cyber warfare, and the whole idea was there couldn't be human intervention, and the bots that were attacking one side, if they became compromised, they had to kind of self-heal before they went back on the attack. And so I know there's some advanced research in those areas, but and some of our guys were involved in those programs. But what I would say in general is kind of self-healing side is there are some good AI programs that if you do are doing integrity checks and validation of code that's out there. If you do find there are, malware and other things that get inserted, you can kind of cleanse that, in an automated way. So I don't know if that quite gets to the question around the data itself, but certainly there are movements to, try to automate the cleanup of some of these attacks. And so if you want to discard malware or discard, the attacks in certain ways, you certainly can do that. Obviously, you still want to prevent the attacks, but you can discard things in automated ways as well.
I mean, certainly what we do, but more in the lab and then actually out there in reality, is to use artificial intelligence techniques to try to be as adaptive as possible. And at the moment, I mean, okay, so I guess we use a fair amount of artificial intelligence on our back end and trend. But where I really see some potential is when we can push more of that out into the actual endpoint systems, and I think that's happening. But I'm not as in touch with the products as maybe William is.
Fair enough. Fair enough. Well, you got a few questions have come in around how do I know what I don't know? More specifically speaking, I mean, how do you detect if a piece of equipment has or has not been compromised or infected if you're not seeing symptoms? Anyone have any thoughts on that?
Yeah, I mean, it's actually kind of difficult. I think a lot of this is Joe, by the way. There's a lot of data out there that shows that if you've been compromised, you may not see that for 180 days or 270 days and the like. And certainly there's techniques that where exploits or malware is inside kind of a network, and the attackers have done things to kind of obfuscate the detection, the signatureless kind of malware, if you will. And so they've become very good at kind of hiding and lurking. And so, with that, certainly having, various levels of protection. Obviously, you want to have intrusion detection to make sure things don't get in the first place, but oftentimes those things are beaten. And so, there are anomaly detections looking for changes in behavior and things like that might suggest something is askew. And then there's certainly kind of alerts and reporting to suggest, that something has happened. And so, if you don't know that it's out there, you don't know how to detect it, and you don't discover it until after the attack has occurred, then obviously a lot of damage can be lurking out across critical infrastructure. And so, one thing that I think people are doing is kind of on a regular basis doing integrity checks and validation, but, obviously layering in, different forms of protection and prevention is critical, because what you don't want to do is find out after, 270 days that it had been there for a long time, and they were just waiting for the right time to administer an attack. So having multiple layers of defenses can minimize it. But certainly, doing your best to prevent things as well is critical.
And I think one advantage that the OT world has compared to the IT world is that it's far less dynamic. So once you have deployed, IDS products, you have the potential to track anomalous traffic a lot easier than you do in the IT world, which is a lot more dynamic with like laptops coming and going, phones coming and going off in and off the network. But in the OT world, you can clamp down on these things a lot better.
That's a good point. Kind of in that same vein, I mean, this is more of a rhetorical question, but why do you folks think there's so many devices connected to the internet? It keeps going up exponentially.
Because we can. I'm actually surprised.
There's multiple factors. Yeah, go ahead.
No, go ahead. I was just going to make a snarky remark there.
Yeah, I mean, there's obviously a variety of factors. I mean, there is the promise of productivity and efficiency and decisions on the edge where, if you're thinking about kind of transportation and logistics in general, having data that can report back, to a centralized location about conditions is helpful, and also having data that can be, where analytics can be applied on the edge. These are drivers to improve or increase productivity. There's also then the promise, and I think we all kind of experience the benefits of mobility in today's world, and mobility kind of enables people to be more efficient with their time, or the promise of kind of in some ways a better work-life balance. And so the combination of productivity, analytics, mobility is kind of the driver. And of course, obviously for this forum and this discussion, that can tend to lead to increasing attack surfaces. but making better decisions, increasing productivity, increasing mobility. These are all, good things to pursue. And certainly, I think, at least from our perspective, we think that security can be an enabler of all those things and doesn't have to be a detractor. So, the best we can is to kind of embrace that, but be mindful of the threats.
Yes, I would definitely agree with that.
Yeah, the one thing that I would add is that in terms of having devices that are connected, it can be quite simple sometimes to be able to calculate ROI on that. You have a use case, you have a set of data that you haven't had before, or that you're now getting in a more granular fashion, and you achieve, greater accuracy or greater safety or greater productivity, and that's measurable. So I think that's one of the drivers for a lot more devices being on the internet.
Excellent. Well, I have a couple more questions. I think we're getting close to the wrap-up time, so maybe we'll table a couple more of these. This just came in from Pamela. She says she's chaired a security self-certification framework for IoT and IoTSF, and she'd like to get the panel's thoughts on creating a directory of secure things.
I could say that's going to be a very short list, but
yeah, and I like the idea. I mean, if there are certain things that that become, good practices, a place to kind of see what other, what are, different companies doing and who meet certain, criteria is certainly a good thing. I think if you can find a way to share that where the list itself doesn't become a target, I think that's even more, or that is also important. But, I love the idea of collaboration and, sharing information around best practices and coming up with a way to help, many organizations kind of evolve the maturity of their security posture. I would embrace that. And certainly, that can lead to informing consumers and buyers of different products as well. But I think it has to be protected somehow, because whenever something gets published, it can tend to become a target as well. So there's, a balance there, like with everything else.
Fair point. We had actually several inquiries come in just for use cases. And if the panelists have anything in the area of food and beverage or confectionery industry, I think there's several people in the audience that would be interested in hearing more about that. May not have time to table it today, but if you've got something, we can definitely send it out for follow-up.
I think that was specifically for AR.
Correct.
Yeah.
Correct. I'm sorry. Very good. Well, maybe as a final wrap-up question, one come in from Sumita. It says, how far are we from auditing security in the convergence of IT and OT?
I think a lot. I think there's actually a new breed of pen testers who are specialized on the OT field, and I co-host or co-organize a conference in the München area. And a lot of the people who come there are actually quite specialized in basically to pen testing, auditing these sort of environments. And it is kind of very special. Like if you're auditing cars, it's very different from auditing a factory. So I think it's happening. It's probably not really that mature yet. But there are people who are doing it in an increasing way. And we have, like in our team, we have 2 people who are very specialized in exactly this sort of stuff. That's what they did that for a living before they joined us, and now they're into more advanced threat research.
Very good. So just one parting question. From the panel's perspective, we've talked a lot about are seeing examples of what's going on the sea and on land from a transportation standpoint. But what are your thoughts on vulnerabilities in the air as we start to see more and more Wi-Fi enabled aircraft? Any thoughts there?
Yeah, I mean, there's plenty of examples with drones and even military kind of assets, if you will, of compromises. And so, you know, again, I think drones offer tremendous benefit in many different use cases. And perhaps, you know, delivery and logistics becomes one of those kind of, you know, in the future. But again, if there's a common vulnerability across all drones, then they become immediately, subject to a potential attack. And certainly if the drones themselves are compromised in the supply chain, you can see that, you know, there may be, people that are, you know, kind of coordinating these things. And so I think I just read that the state of, the new city of New York, just today made a large purchase of drones with federal dollars, and one of the questions is that secure? So I think there's a lot of interesting kind of questions, but along these lines, then also I know TSA, for example, has just issued its roadmap on protecting TSA's kind of infrastructure and all the things that they're doing to protect and provide security. And so in both areas, I think it lends to, certainly some significant vulnerabilities that need to be addressed.
So I have the benefit of living in a city which also hosts a very large plane manufacturer, and it's not Boeing. So I talked to them about security, and it turns out that the cockpit systems and the cabin systems are actually connected, which is something that as a design decision I would not have made, but they explained to me very patiently why they have to do it and what protections they have in place. And so while it still remains a concern, and one of the issues, of course, is that these have to be standardized across the world. It can't be just one manufacturer. It has to be, everybody has to comply by the same standards. They certainly are trying to address any potential issues. And so far, I haven't seen any cross, like cabin to cockpit attacks. I've not seen it, but, we don't see everything.
Yeah, there was also that initiative that GoGo, which provides a lot of the in-flight entertainment and internet access on a lot of airlines. They started up a bug bounty program a couple of years ago because of the concerns about people trying to gain access to cockpit systems from in-flight entertainment. Yeah.
And certainly one of our researchers found a way of hijacking, I don't think it was GoGo, but it was some other system, some Wi-Fi system in a plane through some really, really old attack or so, which still worked apparently on that system. So there are some things to do.
Very good. Well, on behalf of IIoT World, I want to thank our panel, Jeff, Morton, William, and Joe, for an outstanding presentation this afternoon. I want to thank all of our attendees for joining us, and please stay tuned for other educational webcasts brought to you by IIoT World in the coming months. We've got the following topics that are scheduled now. We've got predictive analytics and maintenance coming to you in January 17th. There's an industrial cybersecurity webcast on healthcare on January 23rd. And we have two that are in the works for driving ROI out of IIoT, as well as connectivity, AI, and IIoT. And special thanks once again to our sponsors this afternoon, Trend Micro and Run Safe Security, for this educational series. Please feel free to subscribe to our newsletter or our YouTube channels, and you can follow us on Twitter, or you can do all three. So thank you once again for attending today. Take care, and we will be in touch with you soon.
Thanks a lot. Bye.
Thank you.
Bye.